The topic is hierarchical clustering. We produce a nested sequence of clusters tree called dendrograms. So types of clustering are agglomerative or bottom-up clustering. So it builds the dendrogram tree from the bottom level. So we have separate points here and then we group similar points to form the clusters till finally one cluster only is there. Divisive or top-down cluster, it starts with the data points in one cluster. We start with the root node and then divide it into clusters till finally we get one single point in the end. Agglomerative clustering, it's popular than divisive method, which is the bottom-up approach. So at the beginning, we start with each node and then go on merging till we get the final one cluster. Step 1, make each data point in the D as a cluster. Compute all pairwise distance of x1, x2, all the distances. Find the two clusters that are nearest to each other. Merge the two clusters and form a new cluster C. Continue this till finally only one cluster is left. Measuring the distance of two clusters, we have some few methods. Single link method. The distance between the two clusters is the distance between two closest data points in the clusters. Like when we have two clusters here, two closest data points distance is single link method. Complete link method, distance between the two farthest data points. But if the farthest data points is an outlier, then it becomes an error. Average link method, the distance between two clusters is the average distance of all pairwise distances between the data points in two clusters. Centroid method, the distance is the distance between their centroids. Time complexity is order of n square. For single link method it is order of n square, and average link method order of n square log n. Distance function, there are many distance functions for different types of data, numeric data. Most commonly used functions are Euclidean, these are the distance measures. Euclidean distance is common one, root of xi1 minus xj1 whole square plus xi2 minus xj2 whole square, like that it goes on. Weighted Euclidean distance, we multiply each difference with the weight also, w1, w2, etc. Manhattan distance, mod of xi1 minus xj1 plus mod xi2 minus xj2, etc. Squared Euclidean distance, xi1 minus xj1 whole square, we don't have the square root here. Chebyshev distance, maximum of all the differences. Problem, given a data set, you are using KNN regression with k equal to 3. What is the prediction for the new input values 3, 2? Use Euclidean distance measure. So for each pair 2, 5, we find the Euclidean distance. So root of 2 minus the value given here 3 plus 5 minus the value asked in question 2 whole square equal to root 10. So like that we find the distance for each of these data points to the question asked data point 3, 2. The distance least is root 1 and root 1, which are for data points 3, 3 and 2, 2. So the closest data points are 3, 3 and 2, 2. Y of 3, 3 is, for 3, 3, y is 3, for 2, 2, y is 2. So average of 3 and 2, 2.5 is the value for the new input value. Then binary functions for, thank you.